Welcome back to the Get Willy computer classes. Learning computer with seeing the natural sights of village, Indian village or Bharatiya village. Now in this lecture we will talk about the main memory organization. In a main memory of a computer system consists of several small storage area called locations or cells, and each of these locations can store a fixed number of bits called the word length of the memory. A given memory is divided into n words, where n is generally some power of 2. Each word or location has a built-in and unique number assigned to it. This number is called address of the location and is used to identify the location. Each location can hold either a data item or an instruction, and its address remains the same regardless of its contents. The first address normally starts at 0, and the highest address equals the number of words that can be stored in memory unit. For example, if a memory has 1024 locations, its address ranges between 0 and 1023. Hence, at address 0 we find the word, at address 1 a second word, and at address 2 a third word, and so on up to the final word at least at the last address 1023. There is an important difference between address of a memory location and its content. A memory is like a large cabinet having as many drawers as there are addresses in a memory. Each drawer contains a word, and the address of each word is written on the drawer. If we write or store a word, say 10101010 at address 125, it is like placing the word 10101010 in the drawer labeled as 125. Later, reading from address 125 or 125 is like looking in that drawer to see its content, which is 10101010. We cannot remove the words at an address when we read its content, but its content changes when we store or write a new word in it. Hence, entering data into a storage location is destructive of previous content, but retrieving data from a location is non-destructive. The act of entering data into a storage location is called memory write operation, and the act of retrieving data from a storage location is called memory read operation. So we have two operations here, memory write operation and memory read operation. Hence, read is a non-destructive operation and write is a destructive operation. Now, why bits? Why we should use more bits? We might have heard about a 16-bit computer, 32-bit computers, or 64-bit computers, etc. They refer to a memory word length, total number of bits per memory word. Of a computer. Word length of a small computer is 8, 16 or 32 bits, whereas that of a large computer is 64 bits or more. The obvious question is that what is the advantage of having more number of bits per word instead of having more words of a smaller size or length? To answer this question, imagine a highway with 8 lanes and a heavy flow of traffic. If we expand it to 16 lanes, traffic flow speeds up considerably. 8 bits is analogous to the number of lanes on a microchip. More bits mean more rapid flow of electronic signals. In other words, a faster computer. More bits represent more flow of electronic signals, and this gives computer a faster way. Hence, the amount of data that an 8-bit computer can transfer to and from memory in 1 minute, a 32-bit computer may transfer in a few seconds. Data and instruction move to and from memory as one or more words at a time. Therefore, even if the electronic circuit used are comparable in speed, computers having a smaller word length will be slower in operation than computer having larger word length. This difference is analogous to providing the user of a computer having a smaller word length with a small data so well, and the user of a computer having large word length with a large data so well. Even though they both may be swelling at comparable speed, the user with a smaller shovel will be slower because she needs more shovelfuls to move the same amount of data. The next topic is fixed and variable word length memory. The main memory of some computers can store a fixed number of characters equal to its word length in bytes in each numbered address location. Such computers are said to be word addressable, and they employ a fixed word length memory approach. These computers always allocate a storage space in multiples of word length. Therefore, if a word addressable computer has fixed word length of 4 bytes, that is 4 characters, it will require one word of 4 bytes to store the word like rat, R-A-T, and 2 words requires 8 bytes to store 8 bytes like the word Bombay. In many computers, main memory is designed to store a single character A, B, C, D, comma, 1, 2, plus, minus, $, etc. at each numbered address. Computer designed in this manner are said to be character addressable, and they employ variable word length memory approach. Hence, in these computers, only 3 bytes are required to store the word rat and 6 bytes to store the word Bombay. We can see the difference between fixed word length and variable word length memory approaches. Both fixed and variable word length memory systems have their own merit and demerit. Normally, large scientific computers use fixed word length approach for gaining a speed of calculation. On the other hand, small business computers use variable word length approach for optimizing use of storage space. For example, let us consider a fixed word length memory computer with a word size of 8 characters. If most of data words to be stored are of less than 5 characters, more than half of its storage space will remain unused. This will not happen in the case of a computer with variable word length memory because it can place a character in every storage cell. However, word addressable computer possess faster calculating capability because they can add two data words in a single operation. If word length of a computer that uses fixed word length approach is 8 character, it can add two 8-digit numbers in a single operation. On the other hand, a character addressable computer can add only one digit in each number during a single operation and would need 8 steps to add two 8-digit numbers. We can design a computer to employ either fixed word length or variable word length memory organizations. These computers have an instruction set using which we can operate them as either variable or fixed word length memory computers. However, with memory becoming cheaper and larger day by day, most modern computers employ fixed word length memory organization.